Find an equivalent expression. Well, that gives me tons of direction, right? We got to turn this thing just into something different. Like, what else could this equal? That's actually a lot of freedom, so this can be a tough question. First thing is, make an equivalent expression. Well, when I look at this, the first thing I think about is that reminds me just a whole lot about maybe like just sine of x. So if I just think about sine of x, well, this is different than just the sine of x. It says the sine of x plus pi over 2. We're just adding some stuff in there. What that actually reminds me of is just kind of like good old y equals x squared. This is just a basic parabola, but what if we had something like y equals, well, maybe some other crazy junk in there, like x plus 2 and then squared. So what if there's extra stuff inside our problem that makes it more complicated? Well, if you remember, this just means we're going to shift the graph of the original one. We're going to shift the graph of this guy to the, this is what, shifting to the left. It says a plus 2. That actually means, though, to the left. It's actually going to shift to the left or to negative 2, which means if this original graph, if you remember what that guy looks like, this guy actually is a parabola that looks like this. So when we graph the shifted one, this guy will actually just be shifted to the left, 1, 2, and then we draw our normal parabola right there and graph it. Okay? So the graph is very helpful for shifting and thinking of it in a new way. So let's actually do that over here. Let's actually graph, I'm going to graph the original sine. And the original sine, if you remember, it starts here at 0 and it goes up and then down and then back, and that's a full cycle. And of course it actually keeps repeating and it keeps going. And of course there's even some this way and it keeps going, right? Well, what is this whole thing? We're actually supposed to do the sine of x plus pi over 2. Well, how does this relate to like the parabola situation? Well, it's just like this guy, only it's got this plus pi over 2. You should think of that as a shift, shifting the graph. And this is also shifted, since it's a plus, it's actually shifted to the left. So it's shifted to the left, and it's going to be over at negative pi over 2. Now I say it's going to be over at negative pi over 2. Remember, for the parabola, the original one starts here at the origin, so when we shift it to the left, 2, that main point gets moved to a new spot, to the left 2. So let's actually do that here. This, in fact, let me draw a new sine, a shifted sine below this one, just to kind of get the idea. So this point here at the origin is actually going to shift over pi over 2. Now, okay, if I'm going to move that thing over, I got to kind of know where pi over 2 is. I got to have some sort of reference points. So first off, this is of course 0. The end of the cycle is at 2 pi, and in the middle of the cycle, which is right here, is actually at pi. So pi over 2, if we're thinking about like half of a pi over 2 is actually right here. This is a pi over 2 point. And so the one at 0 is going to shift over like here, and that's pi over 2. That's great. That 0 here will move over. There we go. But actually, another one to move is this pi over 2, halfway to pi. This one's also going to move over, but that'll end up back on the y-axis. So this one that's actually up here is going to scoot over and become my new y-intercept. And of course, we can shift all these points. This other point here at the on the x-axis is going to shift over half a pi. Remember, we're shifting it negative pi over 2, or half a pi to the left. So that means this point is going to move and actually still be on the axis right here. That'd be something like right here. Okay? And then we can, of course, shift all these. But you know what? I already kind of have a good visual on the shape of this. It's going to go down and back up and keep going like that. Okay? In fact, I could draw the dotted line. Wait, in fact, I could draw the dotted line this way. What is this starting to look like? If I highlight a portion of it, it starts here on the y-axis up at 1. It goes down, and then it back up, and now it completed a full cycle. And remember, this one had a full cycle of 2 pi, so even when we shift it, it's still going to have a full cycle of 2 pi. But now we're looking at our cycle in a new way, starting at the top, going down, and then back up to the top. If I mark a couple more of these main points, this should look familiar. This part right here, this whole thing now, is actually the graph of cosine of x. That's just the original cosine. Here's what this means. That means if you shift the sine over to the left, pi over 2, which is what this math says, it's actually just the same thing as good old cosine. This is my answer. I took this expression and I found another one that's equal to it. It's exactly the same. So if I shift this guy over, it's exactly like a cosine. And that's my answer for it. Okay, let's try another one, because this is kind of an interesting thing to consider, like making a new expression out of it. All right, so now that we know our sort of philosophy, let's look at this. This is a cosine. Well, this reminds me of good old cosine. Here's just a basic cosine. In fact, let me graph a basic cosine. Remember, cosine, which we just discovered on the other problem, cosine starts here, goes down and then up, and of course, you know, it keeps going and keeps going. And this, of course, is a full cycle, which is 2 pi. This starts at 0, naturally. And the middle of there, in the middle of 0 and 2 pi, is just a pi. So this is pi right here. And of course, this would be halfway to pi, or pi over 2. And this is in between there. But let's look at our new modified thing that we actually need this. We need cosine of x minus pi. That looks like we need to take this and shift it to the, wait, it says a minus. That actually means shifting to the right by pi. So I got to shift this thing this way, which means this main dot at the top is going to move over here. Okay, so let me get this started. Let's get a little bit more room here, though. All right, so let's graph. Let's do another graph just below it, but let's shift it over. So instead of starting up at the top here, it'll shift over, and that's where it will be at pi. So it'll be zoop, moved over, and it'll be up there instead of back here at the origin. It's moved over. Now, since I'm moving things to the right, it's kind of hard. Like, all this is already far right. And true, I mean, I can move this guy. This guy is at 2 pi. If I move it to the right a whole other pi, it will be at 3 pi, somewhere way out here. We're getting pretty far out there. So if I shift way out, of course, here's 2 pi. But if I shift this guy way out to 3 pi, I mean, this guy will be out here. I'm just getting a little too far. So you know what? Let me actually draw some of this backwards, back in the negatives. Okay, so a full cycle negative like off to the left would be negative 2 pi. And the advantage of doing this is if I graph some stuff to the left, when I shift it right, it'll get back to normal. Okay, so right in the middle of 2 pi and 0, a negative 2 pi and 0 is actually a negative pi. In fact, check this out. This dot down here at negative pi, when I move it to the right, it'll get bumped over here back to kind of normal region I like to look at. So it's down here at -1. For negative pi, it's down at -1. So zoop, when I scoots it over a full pi, it would be right back on the y-axis. But it's down here at -1 because it came from over here and I moved it over. So that's its new spot. Okay, let me erase that. So I already start to see some of the shape. Let me just move another point here if this one makes sense for you. This one is halfway to the negative pi. If I move it a full pi, remember we're shifting it a full pi to the right, that means it's going to go here and it's going to go half a pi and then another half a pi to be a full pi. So this 0 here moves over and it just moves over to this spot. So it's actually going to be right here. Notice the 0 moved to the 0 on the x-axis. In fact, this 0 here would move over to this 0 right here on the x-axis. I'm starting to see the shape here. This must like curve and it must go whoop, whoop. Now where's it going to go? I think it's going to go down here. It's going to cross here at the halfway point. Remember, all the halfway points were still moving bloop to each other, matching. And then it goes here, like we thought. Of course, this keeps going, and of course, this keeps going. All right, now what does this graph look like? Well, wait a minute. It almost looks like this guy, except it's just kind of upside down. Like what used to be down here below the axis is now bloop, above the axis. What used to be above is now shifted over to where it used to be below. This is actually just a flipped version of cosine. What's a flipped version of cosine? This is actually just negative cosine of x. So here's what that means. That means if we shift this thing, if we take this whole thing and shift it, or if we shift the original cosine, we just get a flipped cosine. That means that a cosine of x minus pi, or shifted to the right, is just like a flipped cosine. So it's equal to negative cosine. We just found an equivalent expression for this weird thing. We just turned it into a nicer thing that's equal. It's the same thing. Of course, as we did before, if you wanted to, when in doubt, test it out. You could actually just try a number just to make us feel good that this is correct. You could plug any number you want in for x. Let's just plug in 0. If I plug in cosine of 0 minus pi, is that equal to negative cosine of 0? You could test that out on a calculator, or if I just do some quick thinking here, I know the cosine is 0. Cosine of 0, according to this original cosine graph, is 1. But there's a negative weighting out front, so it actually becomes negative 1. Now, what is the cosine of 0 minus pi? Well, that's actually just the cosine of negative pi. And if I look on my graph here, the original graph, the original cosine, before I shifted it to the right, the cosine of negative pi is also down here at negative 1. So that means that, yes, this side was negative 1 for this guy. And of course, yes, this side was also negative 1 for this guy. They are equivalent. They really give us the same thing. And so we found an equivalent expression. Our answer is negative cosine of x.